In this video, I'm going to talk about my multimeter, why it might be inaccurate, and whether that actually matters. Now, logically, we probably should start with what do I use a multimeter for? The problem that I'm having is with DC volts in this one. And so I'm using this multimeter to check lithium battery cells. And the reason I think there might be a problem was I bought myself a new battery charger for my electric Brumby. And so that charges up to roughly 176 volts, something like that. It has a maximum of 180 volts. Anyway, I set it to a particular voltage. You can change what voltage it charges up to and turns off. And it turned off, and when I checked the voltage against the battery management system, the BMS was saying a different voltage than what the battery charger was set to. Did a little bit of fiddling. I found that the battery charger was always a little bit low. Checked the voltage of the battery pack against the multimeter, and the multimeter agreed very well with the BMS. And so originally I thought, oh well, maybe there's just something, it's just a little bit inaccurate, that charger. And so I just set the charger to charge up to a volt more than what I needed. And that seemed to work fine. But then one day I thought, well, hang on, the BMS, how does that know what the voltage is? And the way it knows what the voltage is because I built the BMS to start with, and I calibrated it. What did I calibrate it against? I calibrated against this multimeter. And so really I was reading the two, it looked like there were two things reading one value and one reading a different value, but there was actually, these two things were the one thing. And so I've really only got two values. So which one is the correct one? Anyway, how accurate do I need it to be? That's the question. So what I was talking about there was 170 volts or something and a 1 volt difference. But the most important thing that I need to know is the cell voltage. And so cell voltage is around 3 to 4 volts. And so what I really would like to know is how accurate do I need to be at that 3 or 4 volts value there. So let's look at some numbers. There are 3 reasons I want to know the voltage of my lithium cells. One is to make sure they're not too discharged. So once they get very low voltage, I need to be able to stop the discharge, sound an alarm, those sorts of things. And the same when they get to high voltage. So as I'm charging them, I need to be able to turn off the charger when they get to a certain voltage. The other thing is I need to be able to balance them. And so I've got a battery management system that looks at the voltage of every cell in my string of cells. And if one's a little bit high, then it'll take some out of that one. If one's a little bit low, it'll put some into that one. So they're all the same voltage. I've got 2 main lithium cells that I'm looking at. I'm looking at LFP, lithium ferrophosphate, and NMC, what's that? Nickel, manganese, cobalt, something like that. This is a LFP cell here. The voltage for those, let's use the example of 100% charged. So with a lithium ferrophosphate, I've written down here, 100% charged around about 3.4 to 3.6 volts. If it's a voltage around there, you know it's fully charged. So the accuracy that I need when I'm measuring an LFP is not terribly accurate. So 0.1 volt would be fine. The difference between, 0.1 volt would be fine. With NMC cells, I've got a little table here that shows you the state of charge with NMC. And so with LFP, 3.4 and 3.6 is both 100% charged. It doesn't matter whether I stop at 3.4 or 3.6 really. But with the NMCs, when you get high here, it's still changing it's not changing very much voltage per state of charge. And so the way this table here works is at 0% state of charge, we have 3.167 volts, and it goes up and up and up, 45%, 50%, all the way up to 100% at 4.166. Now, if you look at the difference between 100% and 90%, it's about 0.1 of a volt. So 0.1 volt on an NMC cell represents about 10% of the battery capacity. So we definitely want to be more accurate than that. How accurate do we want to be? Well, 0.01 volts would be 1% of the battery, and that sounds reasonable. So how accurate should this multimeter be? Now, this particular one is a Digitech QM1548. So looking online, I found the precision section of the user manual. So the first thing here is we're looking at the range of 20 volts here. That's where we can get 4 volts. You have to be not in 2, but in 20. And it's saying the resolution is 10 millivolts. Now, all that means is that it can read to 0.001 of a volt. So the display here, it's pretty obvious. That's what it means. So 0.01 of a volt is 10 millivolts. But the accuracy is what we're interested in here. And the way it expresses it is 0.5% of the reading plus 1 graduation. Now, 0.5% of the reading. 4 volts, let's just divide it by 100 to give 1%, is 0.04. And so divide that by 2 to give 0.5% is 0.02 volts. And then it's 0.5% of the reading plus 2 graduations. Sorry, plus 1 graduation. We're up on this one here. So that means 0.02 volts plus 1 graduation. What it means is one of the final resolution digits, and so it's 0.03 volts. So if we go back to our little table here, so it was 0.5% of reading plus 1 graduation. And so if we say 4 volts, that is, what did we say? 0.03 volts. It's plus or minus 0.03 volts. So what that means is that if it's reading 4 volts, 4.00 volts, it could be anywhere between 3.97 volts and 4.03 volts. So for my LFP cells, that's fine. For my NMC cells, that's not good enough. So when I figured this out, I decided I probably just need to go and get a more accurate multimeter. And so I went into town looking for multimeters. I bought this one years ago from JCar, and I thought, well, they might have more accurate multimeters. No, everything they had exactly the same specifications as what this one was. So I went to some electrician shops that sell Fluke multimeters, much better brand than the Digitech ones. They also had exactly the same specifications. You could buy $1,000 worth of multimeter and it would still be the same accuracy specifications. So what I ended up doing, I did find a better multimeter, and the way that I found it was I went on to, it was Element 14 or RS Components, one of those big online stores, and they had lots of different ones available. It wasn't terribly easy. They don't have the specifications on the front page, so you sort of had to go into each one, look at the user manual, figure out what they were, and then go back and write them down. They were almost all the same, but I did find one reasonably priced that had a better specification. And this is the multimeter here. So this is a 10 multimeter, and I'll show you the specifications. So into the user manual, very extensive user manual. And there's the DC voltage section there. And so what it says is 0.1% plus or minus 3 digits. How does that compare at 4 volts? Let's have a look. So we've got 0.1% plus 3 graduations at 4.000 volts. So this one has a resolution of 3 decimal places, so 0.001. And so our graduation is going to be 0.003, but the 0.1%, so 0.1%, 4 divided by 100, that's 1, divided by another 10 is 0.1%. So we've got 0.004 plus So 0.004 plus 3 is 7. And so essentially what we have here is very close to plus or minus 0.01 volts. And that's, I think, good enough for my NMC. If it's that, then that's 1% of my battery capacity. So as well as precision from your user manual, there's also calibration. Now, ideally, I would get this calibrated against a proper standard. Take it to somebody with a properly calibrated multimeter and voltmeter and check it against it. I'm not going to do that, but I am going to test this voltmeter against my other voltmeters that I have. Decided to do a calibration between the voltmeters that I have here. So what I have is my new, theoretically quite accurate multimeter here, the 10 and I have a DC power supply to provide my DC voltage. I have a Digitech QM1634 clamp meter. It's new. It's got the same accuracy as the older meter that I have here, the older Digitech, but it has a higher resolution, has 3 decimal place resolution. And I have my old QM1548 Digitech multimeter, which is the one that I'm concerned with. So I'm going to use the 10 as my reference in this calibration. Normally you would, if you're going to do this properly, you get this calibrated against an external reference. I'm not going to do that. I'm going to rely on the fact that the specs are quite good on it and it's new. Okay, so turn on my power supply. I've decided what I'll do is I will do various voltages. I'll go 1, 2, 3, 4, 5, and then keep on going up to the highest voltage that my power supply will provide, which is about 30 volts. Okay, and so at the moment I've got voltage there. I'll set the voltage on this to be as close as I can get to 1 volt. This has got 4 decimal places. And so setting that to 1.00 looks like 1.0003, 2, which is pretty good. So let's put that into the spreadsheet. 1.0002 volts. To get that, the power supply was 1.00 volts. Now our clamp meter, I've got it wired into the other meter there. Turn that on to voltage. And it's saying 1.001. And then this one is reading low to 0.993. Then the next point is 2 volts. 2.001. 2.00. 2.003. And 1.98. 3 volts and so on, and I'll do it up until 30 volts or so and show you the results in the table afterwards. Okay, I finished my calibration. You can see from the numbers there that the power supply is reasonably good. It's a lot more accurate than I thought it was because I've always been comparing it with my multimeter, which has not been accurate. My new multimeter, it's actually slightly worse than the power supply actually at telling me what the voltage is, but it's pretty good, especially compared to my old multimeter, which is a fair way out. It's still, I think, within specification, but only just, and it's not as good as I'd like it to be. So there's my calibration. I can now know how bad my various instruments are. This multimeter, I need to be very careful measuring DC volts to make sure that it has the accuracy that I need for any particular application. I'm not going to throw it out just yet. I'm sure it's fine for other readings. I'm not sure it's fine for other readings, but I probably don't need that accuracy. And so I'll just keep that in mind if I ever am reading something that I need to be accurate, to go and check it against something else. This new little one looks good, and so maybe I'll start using this one as my portable multimeter now. But this one, whenever I need some accuracy. Being not portable makes it slightly less convenient for some things, but that's the price you pay for accuracy in this case. Thank you for watching. Next thing I need to do is go and recalibrate my battery management system.